Debugging and acceptance of automatic fire alarm systems. Task 1. Debugging of the automatic fire alarm system. Hello, everyone. Today, we are going to learn debugging of the automatic fire alarm system. We will divide this unit into 2 lessons. Today, we will cover the first lesson. To ensure that the newly installed automatic fire alarm system can be safely and reliably put into operation and that its performance meets design requirements, a series of adjustment tests must be conducted after the system construction is completed and before it is put into operation. System debugging should include functional testing of system components and testing of the linkage control functions of subsystems. The debugging of the automatic fire alarm system should be carried out after the system construction is completed. So, what preparations should we make before debugging? Before debugging the automatic fire alarm system, we should have the necessary technical documents and other essential documents required for debugging, including system diagrams, equipment layout plans, wiring diagrams, installation drawings, and fire equipment linkage logic descriptions. The debugging unit should prepare a debugging program before starting and should work according to the program. The debugging manager must be a professional technician. Each component of the system, including the fire alarm controller, combustible gas alarm controller, fire linkage controller, gas fire extinguisher controller, fire electrical control device, emergency power supply, fire public address, fire telephone, transmission equipment, graphic display in fire control center, fire electric device, fire shutter controller, area display, fire indicating panel, fire emergency lighting control device, and fire alarm devices should undergo individual power on testing. First, let's learn about the debugging of the fire alarm controller. Before debugging, all external control connections of the fire alarm controller should be disconnected, and components such as fire detectors and manual fire alarm buttons in one of the bus loops should be connected before power is turned on. According to the current national standard, Fire Alarm Controller, GB 4717, the following functional checks should be carried out using observation and instrument measurement methods, and records should be kept. The requirements are as follows. 1. Check the self-test function and operation level. 2. Create open and short circuits between the controller and detectors. The controller should issue a fault signal within 100 seconds. In a fault state, if any non-faulty detector issues a fire alarm signal, the controller should issue a fire alarm signal within 1 minute and record the fire alarm time. Then, check the controller's re-alarm function by triggering other detectors. 3. Check the mute and reset functions. 4. Create open and short circuits between the controller and the backup power supply. The controller should issue a fault signal within 100 seconds. 5. Check the shielding function. 6. Create a short circuit at any point within the protection range of the bus isolator and check the isolation protection function of the bus isolator. 7. Place no less than 10 fire detectors in the fire alarm state simultaneously on any bus loop and check the controller's load function. 8. Check the automatic switching function of the main and backup power supplies and repeat item 7 under backup power operation. 9. Check other unique functions of the controller. 10. Connect other loops to the fire alarm controller and repeat the checks. Next, let's learn about the debugging of point-type smoke detectors and heat fire detectors. Use specialized testing instruments or simulate fire conditions to check the alarm function of each fire detector individually. The detectors should be able to issue a fire alarm signal. For non-resettable fire detectors, use simulation methods to check the alarm function of each detector individually. The detectors should be able to issue a fire alarm signal. If there are spare detectors, their alarm function can be checked by sampling. How is the debugging of linear heat fire detectors conducted? Simulate fire and fault conditions on non-resettable detectors and check the fire and fault alarm functions of each detector individually. The detectors should be able to issue fire and fault signals separately. For resettable detectors, use specialized testing instruments or simulate fire conditions to make them issue a fire alarm signal, and simulate faults at the terminal box to check the fire and fault alarm functions of each detector individually. The detectors should be able to issue fire and fault signals separately. The debugging steps for infrared beam smoke fire detectors are as follows. 1. Adjust the optical path adjustment device of each detector to ensure the detector is in a normal monitoring state. 2. Use an attenuation plate with an attenuation rate of 0.9 decibels to block the optical path. The detector should not issue a fire alarm signal. 3. Use an attenuation plate set by the product manufacturer, 1.0 to 10.0 decibels, to block the optical path. The detector should issue a fire alarm signal. 4. Use an attenuation plate with an attenuation rate of 11.5 decibels to block the optical path. The detector should issue a fault signal or fire alarm signal. 5. For reflective detectors, conduct the above checks at 0.5 meters in front of the detector. The detector should respond correctly. The debugging steps for aspirating smoke detectors are as follows. Add test smoke to the sampling hole at the end of the sampling pipe one by one, and measure the detector's alarm response time using a stopwatch. The detector or its control device should issue a fire alarm signal within 120 seconds. According to the product manual, change the airflow in the detector's sampling pipe to create a fault state, and measure the detector's alarm response time using a stopwatch. The detector or its control device should issue a fault signal within 100 seconds. The debugging steps for manual fire alarm buttons are as follows. For resettable manual fire alarm buttons, apply appropriate force to activate the alarm button, which should issue a fire alarm signal. For non-resettable manual fire alarm buttons, use simulation methods to activate the alarm button, which should issue a fire alarm signal. This concludes today's lesson. In the next lesson, we will continue learning about the debugging methods of the automatic fire alarm system.